Not alive, not dead, but quite the contrary. Schrödinger's cat is the iconic paradox of quantum mechanics, proposed in 1935 by physicist Erwin Schrödinger. This mental experiment suggests that a cat locked in a box could be simultaneously alive and dead until the box is opened and observed. If you like this theme, don't forget to subscribe to the channel and like the video. Quantum mechanics is full of fascinating and surprising concepts that are worth exploring together. The overlap, although not observed in macroscopic systems, has been verified in elementary particles and molecules. This phenomenon introduces us to one of the main unresolved aspects of quantum mechanics, the problem of measurement. The orthodox interpretation of quantum mechanics, known as the Copenhagen interpretation, establishes a separation between the system and the observer. When the observer measures a property of the system, it causes a collapse of the state, leading the property to have a definite value. Today, we will explore a modern version of Schrödinger's cat experiment using qubits, the basic units of information in quantum computing. Imagine two scientists, Alice and Bob, each with a qubit, and an additional qubit that can decide the fate of the cat. Alice and Bob prepare a cubicle system in an interlaced state and lock the cat in a box. If the cubicle of the system is in state 0, the cat dies. If it is in 1, a cat can escape. As long as they are not observed, the status of the qubit is not defined. However, when one of them observes his qubit, there is a collapse of the interlaced state. If Alice observes first and gets 0, the cat dies. A moment later, Bob observes his qubit, which has already collapsed. This leads to a dilemma. Who observed first? Schrödinger gets angry and brings Alice and Bob to trial. The prosecution claims that it was Alice who caused the cat's death, but the defense brings Einstein to testify about the relativity of time in this context. Einstein argues that, depending on the reference system, the order of the observations may vary. This raises questions about Alice and Bob's guilt, and the judge cannot determine who is responsible, declaring both not guilty. The problem of measurement in quantum mechanics is further complicated by other experiments. For example, in a hypothetical experiment with muons, the temporal order of observations is also relative. This leads us to question the interpretation of Copenhagen and its validity. These paradoxes suggest that Copenhagen's interpretation can be just a tool of calculation. Some scientists wonder if there is an underlying theory that explains these complexities. Perhaps the answer is to unify quantum mechanics with general relativity.